A helix is a type of smooth space curve, that is a curve in three-dimensional space. It has the property that the tangent line at any point makes a constant angle with a fixed line called the axis. Examples of helixes are coil springs and the handrails of spiral staircases. A filled-in helix for example, a spiral ramp is called a helicoid. Helices are important in biology, as the DNA molecule is formed as two intertwined helices, and many proteins have helical substructures, known as alpha helices. The word helix comes from the Greek word a1/4 I to the first I3/4, twisted, curved. Types: helices can be either right-handed or left-handed. With the line of sight along the helix's axis, if a clockwise screwing motion moves the helix away from the observer, then it is called a right-handed helix. If towards the observer, then it is a left-handed helix. Handedness is a property of the helix, not of the perspective. A right-handed helix cannot be turned to look like a left-handed one unless it is viewed in a mirror, and vice versa. Most hardware screw threads are right-handed helices. The alpha helix in biology as well as the A and B forms of DNA are also right-handed helices. The Z form of DNA is left-handed. The pitch of a helix is the width of one complete helix turn, measured parallel to the axis of the helix. A double helix consists of two helices with the same axis, differing by a translation along the axis. A conic helix may be defined as a spiral on a conic surface, with the distance to the apex an exponential function of the angle indicating direction from the axis. An example is the corkscrew roller coaster at Cedar Point Amusement Park. A circular helix has constant band curvature and constant torsion. A curve is called a general helix or cylindrical helix if its tangent makes a constant angle with a fixed line in space. A curve is a general helix if and only if the ratio of curvature to torsion is constant. A curve is called a slant helix if its principal normal makes a constant angle with a fixed line in space. It can be constructed by applying a transformation to the moving frame of a general helix. Some curves found in nature consist of multiple helices of different handedness joined together by transitions known as tendril perversions. Mathematical description. In mathematics, a helix is a curve in three-dimensional space. The following parametrization in Cartesian coordinates defines a helix. As the parameter t increases, the point, y, t, z, t traces a right-handed helix of pitch 2I and radius 1 about the z-axis, in a right-handed coordinate system. In cylindrical coordinates, the same helix is parametrized by a circular helix of radius a and pitch 2I b is described by the following parametrization. Another way of mathematically constructing a helix is to plot the complex-valued function xi as a function of the real number x. The value of x and the real and imaginary parts of the function value give this plot three real dimensions. Except for rotations, translations, and changes of scale, all right-handed helices are equivalent to the helix defined above. The equivalent left-handed helix can be constructed in a number of ways, the simplest being to negate any one of the x, y or z components. Arc length, curvature and torsion. The length of a circular helix of radius a and pitch 2I b expressed in rectangular coordinates as equals, its curvature is and its torsion is. Examples, in music, pitch space is often modeled with helices or double helices, most often extending out of a circle such as the circle of fifths, so as to represent octave equivalency. See also, alpha helix, Bordizza coaxitar helix, collagen, double helix, helical symmetry, helicoid, hemihelix, helix angle, seashell surface, solenoid, spiral, superhelix, triple helix. References